In this video, we are going to work with graphs to describe their general behavior. In particular, we're going to look at the intervals on which the graph is increasing and the intervals on which the graph is decreasing. We're also going to look at where the graph has local highest and lowest points, local maximum and local minimum. We're not going to use calculus to describe this behavior. We've got a graph that's labeled where it is increasing and decreasing, and you can see here that increasing happens here on the left hand side until it reaches this point right here, and that point where the graph turns and then goes back downhill, that's called a local maximum. That's a local maximum, and it is occurring in this equation at the point -2, 16. A graph is said to be increasing if x values are increasing. So here where it says where b is greater than a, those are x values. So if I'm looking at an x value that's larger than another x value, as I'm comparing x values, then the y values are also increasing. So an example of that would be here. If I look at this point right here, that point is the point -16. And then I look at this point, let's say right here, that's the point -3, 8. Notice that the -3 coordinate, x coordinate, is greater than the -4x coordinate, and the corresponding y value is greater than the corresponding y value as well. So that's this mathematical definition of what it means for a function to be increasing. But how we're going to use it here in our class is we're going to look for where the graph is going uphill. As we look left to right, as we pan our graph left to right, let's describe the interval where the graph is going uphill. And so that would be this yellow piece that I've highlighted here, right? Okay, there's another place where the function is increasing, and that would be here on the far right. The graph there is also going uphill. In between those two intervals, we have this interval in which the graph is decreasing. So it's decreasing here in this middle piece. Notice again that here on the far right, we have a local lowest point. So we call that a local minimum. And that occurs at the point -16. Again, the definition of decreasing behavior would mean that as our x coordinates are getting larger, as we pan from left to right, our y coordinates are dropping. They're decreasing. They're getting smaller. And that's what this little box means. All right, so here's another representation of the same graph. Notice that it shows that the local maximum value of the function is 16, which we always describe as the y value, but that it occurs at x equals -2. And the local minimum is -16, and it occurs at x equals 2. Now, how do we describe these intervals of increase? So we will be looking at this interval going from left to right, and we will describe it in terms of x. Intervals will be described in terms of x. And you will see that in our examples. So our increasing and decreasing intervals are going to be described in terms of x. So now let's take a look at some examples of graphs, and we're going to determine the intervals in which they are increasing, in which they are decreasing, and then look at the domain and the range. So look at example number 1 here, and when we're talking about looking for the intervals in which this function is increasing, we want to take a look at where the function, as you read it from left to right, is going uphill. And so if you are thinking that it happens right here in this middle section, right there, you're absolutely correct. And the reminder that I want to give you is when we're talking about intervals of increase or decrease, we are going to describe them in terms of the x values. So we're looking from here, let me put there's a little point right there, to right here at this point on the right hand side. And we want to look and read off what are the x coordinates that represent that yellow section as we pan from left to right. And then my other reminder to you will be that intervals of increase and decrease do not include their endpoints. So these will always be described in terms of parentheses and not brackets. Okay, so I'm going to put a set of parentheses there. Now, on the left-hand side right here, what's the x-coordinate there? Well, it is -2. So that's going to go on the left side of our interval notation. And then as we pan to the right, this is our last point where the graph is increasing. And so what's the x-coordinate there? And it looks like it's a half. So we're going to write 1/2. And that's the interval in which this function is increasing. Now let's take a look at the interval where the function is decreasing, and you may be thinking that's happening two different spots. Well, you would be absolutely right. So there are two intervals in which this function is decreasing. We're going to take a look at those now. Let's highlight them with a different color. So the first interval in which the function is decreasing is this one over here. You see it going downhill, and again, as we're looking at the graph from left to right, that graph is falling, isn't it? So this is one interval in which the graph is decreasing. So I'm going to write decreasing here so that you can have that on your notes. And we have to describe that interval, and it ends right there at that same point we looked at before with our increasing, and that kind of makes sense, right? Since the graph is doing a turn there. It's going from a decreasing graph to an increasing graph and actually has what's called the local minimum there. Let's describe this interval. Well, the highest point, the largest x value, occurs where the graph turns. So when we go to write our interval, that value will be on the left side of the interval. My parentheses, and one more time, I'm reminding you that intervals of increase, decrease, use parentheses, not bracket. Now, what should I put here on the left-hand side? Well, that graph is not ending. So we're assuming that there are arrows here. It does come from -infinity. So it comes from the far left of the number line, and the graph falls until it reaches the x-coordinate of -2, which puts it at this point here where we have that local minimum. Then it starts to rise again. It makes a turn there. We have one other interval where the function is decreasing, don't we? That would be this right there, that portion of the graph. It gets its own interval notation, and usually we will put a union in between the two. So I'm going to sneak it in here. And now this time around, as I look at my x-coordinates from left to right, my smallest x-coordinate is occurring at this turning point up here at this local maximum of 1/2. So that's going to go on the left-hand side of my interval. And then this function is going to keep falling no matter how big x gets, right? And x is getting really big because it's going towards the right side of the number line, isn't it? Infinity. Be careful here because sometimes students will look at the fact that this y value is getting negative, right? I mean, it's getting the y value is here on the far right-hand side of the graph. That is just dropping and it's getting very negative. And so sometimes students will want to really put a -infinity here in this interval. But no, remember that you are describing intervals in terms of x, and x is increasing, isn't it? It's going towards the right-hand side of the number line. Good, I hope that's making some sense. Now, we need to describe the domain and the range. So, as you look at this function, there are no holes. As we look left to right for domain, every single x value is accounted for. So this is all real numbers. The domain is all real numbers. The interval notation is -infinity to infinity. And then as we look lowest to highest point, we have no lowest point, we have no highest point, not as an absolute. The arrows keep going on either end of this graph. And so the range is also all real numbers. Okay, let's look at another example that's similar. Okay, take a look at this example, which is example number 4 in your class notes. And I skipped over the other two because this one's similar to the last one. So I thought you would get a good feel for this. So this time around, we're being asked to find a local maximum. So where do we have a point that is acting as the highest point locally? And that would be right here, wouldn't it? I'm sure you can locate that. So you want to give me the order pair there, and that's -1, 3. So we say that the function has a local maximum of 3 at x equals -1. Okay, where's the local minimum? Down here, yeah, then we've got a little local minimum there. What order pair would that be? 5, -3. So we say then that the function has a local minimum of -3 at x equals 5. Now we're looking for intervals in which the function is increasing, going uphill. And yes, we've got one right here, right at the beginning, left to right. So how would we describe those x values? Well, it's coming from the far left of the graph, isn't it? As you look left to right, far left, so -infinity. And then where does it stop? Where does it turn? And that's at this point where the local maximum is at -1. And always use parentheses. Okay, but is that the only interval of increase? No, there's one more, isn't there? So we have this interval in which the function is increasing, and let's describe that in terms of x coordinates left to right, and that starts at 5 and goes to the far right, which is infinity. Okay, now let's take a look at where the graph is decreasing. So the graph is decreasing in this middle piece right here, and let's describe that. Remember, we describe in terms of x. So it starts at that -1 where we have the local max, and it stops at the local min of 5. Okay, now what about the domain and range? Yes, if you said all real numbers, you're right. So all real numbers, these go on forever and there's no holes. We didn't skip anything. All real numbers. Okay, go to the next video in which we will do some different function shapes. So some more examples. We have a parabola and we have an absolute value function for you in the next video.